record this one more time. Alright, so we got a bastard hip, and here's the hip, fascia. So we got an 1.5 inch fascia here, 1.5 inch fascia here, 1.5 inch. I don't think that really matters, but just to give you the perspective of the dimensions. And we have the lines running through to the fascia. This is like just a graphic thing right here that I have. I'll explain that in a minute. But that would be the whole thing right there, with these lines just representing where it would, the calculation point being here. So this triangle here, this line is going to be equal to the hip width. So this is really just for me. The way I do it is I record all the numbers here, and it lets me get a visual way of keeping it all in my head. So I know I'm calculating for this, and then I write it down. And so basically, but these small triangles just represent the whole run, and this would be like the rise and the run if we're doing the math. And so this is just a smaller proportionate triangle here. But this line and the one on this triangle, those are paralleling. Like, see, this one is paralleling this line, and this one is paralleling this line. So what's the ultimate goal we're trying to do here? Okay, so if the board I gotta move this to get somewhere to draw. If the board is squared off, I can't draw on that. Gotta move it over more. Okay, so if the board is squared off, I can barely draw on it. Right? And, just for example, this would be the angle that has to be cut like that. What we're really trying to do is we're trying to get the distance from here back to that point. And as you can see, it's different. If I square the board off from here to here, and here to here is going to be two way different distances. This one would be like 2 or 3 inches almost. This would probably be more like 2 1/4 or something like that. So what we've got to do is we've got to get this distance and this distance, which those are the same. It's basically the same two triangles. So once you get one, you can already just plug it in for the other side. But to get... Okay, so let's walk through this real quick. So we're looking at... We have this length. That's the only length that we have, and that's going to be... We're just going to go 1.5 as a normal, 2x4. So that would become the diagonal. So from there, we know we need this distance. That's ultimately what we need. We can stop once we get that. So that is part of two triangles. It's part of this one, and it's part of this one. Okay, so if we look at it, this one here, it's actually the run of the smaller one. Okay, so that would mean if I have the diagonal of the bigger triangle, I need to use the rise of the bigger triangle in order to, once I know the rise, I turn the rise into the diagonal, and that lets me get the run of a small triangle, and I'm done. Once I got that, I put that number here and here. Then I use the same factor math, and I take a run of 1.5, and I get the diagonal, add it to this number. Now I have this point all the way to here. I do the same exact thing over here, except on this side, I'm going to be given a rise. I plug that in, and I'm getting the diagonal. Then I add these two, and it's going to give me from this point, I pull that measurement to here. Sorry, it's a little fuzzy. But up at the top, it's not going to be the whole, because I'm not going to this point, I'm going to the center point. That's where it's got a plane in at. So if you square this over here, you make a, the edge of a 2x4, and you do these same kind of like triangles like I have there, it's a lot easier for me to do it facing the other way. But if I were to draw those out like that, you're not going to do the 1.5 inches. It's going to be, it's going to be half the stock thickness on those. So you're changing it. And then it's going to shift it. It's going to shift your board over from where, if you look at this very closely, you'll see that if I were to just put a 2x4 up here, the distance here to this edge and this edge is different. But if I put a 2x4 here, it's going to be 7.5 or 0.75 and 0.75. So 3/4 and 3/4 either way. If I center it, what does that mean? That means that this is going to have to swing over in order for it to fall into that shoulder right there, in order to plane in. So I'm not worried about that anymore. I'm just talking to the camera now, but that's what has to happen, and it has to happen the opposite way at the top. So either way, having it plane in is what counts, and this solves that. Now, if you want to turn around here and actually have me go over this, then you could see here where you get, if we draw these all the way through, then you see how you have your triangles like we had on the other side. It's way more messy. Like that. And the distance here is also going to be different, because on the other side we had the entire, it was like out to here or here, center point all the way through where these fascias would meet like that. So we had it running all the way. So these were bigger. Well, it may not. These sides are going to be different. These are going to be the same, because we're still going off of this whole thickness here. So these triangles remain the same, and then these, you're just adding it to a smaller, because before you were going across the entire fascia. Now you're only going across half of it. So you could say, oh, just take half of that. I don't do that. I'm just going to do the math, because if I start trying to, I will confuse myself really quickly if I try to start making this a guessing game or assuming something. We got some complex stuff going on. I mean, it's not the most complex thing in the world, but if I'm going to calculate it, I'd rather just do it the right way. Not the right way, but the more regimented way. That way it's organized. But anyway, okay, enough of that one.